Welcome to Ask and Learn.
A question does not mention anything about parallel or series capacitance in this case. Now, why am I saying series or parallel? You can realize that after doing this particular calculation. So let's find out electric field. Electric field is V divided by D, and as we are given information, we can find D from this. So V, which is maximum voltage applied, is 100 volt, and electric field strength is 30 times 10 power 6. So if you perform this calculation, you will get 3.33 micrometer. Now, in question, we are given the thickness. Let's say this capital D is it's not 3.3 microfarad, but it is 6 millimeters. It means that we have more than one capacitor. So let's find out how many capacitors we have. So number of capacitor N is equal to capital D divided by small d. So capital D was 6 millimeters, so 10 power negative 3, and the small d is 3.33 times 10 power negative 6. This is 1800 if we perform this calculation. Now, it means that we have 1800 calculators. Now, let's find out capacitance of one capacitor in such case. So that will be C is equal to A epsilon naught K divided by D. Let's substitute the values. We don't know the value of K, so let's leave it for now. Area was 12 times 14. Since both are in millimeters, we should write them in terms of meters. So it gives you the factor of 10 power 6. Epsilon naught gives you 8.8 times 10 power negative 12 divided by D, which is 3.33 micrometer. So this value is, so let me perform this calculation on my calculator. So this value is 446 K times 10 power negative 6. Oh, negative 12, sorry. So as you can see now, even if you have, so if you try to write this in terms of microfarad, so let's see, 446, so 0.446 K times 10 power negative 9, so this is nanofarad. And so assume that value of K. So to have anywhere value given in question of capacitance value given in the question, which is equivalent capacitor 1 microfarad, value of K should be at least 100. And in general, we don't use such large K. So we can safely guess that this is parallel plate capacitors. So how this is achieved is that there are layers of metals like this. So instead of applying, since there are so many metal plates, if you apply potential difference here and here, it means that you are using them as series, and inside metal plates are not doing anything. So in such a case, the capacitors have somewhat complicated structures like this. So alternating plates are connected to, let's say this is positive terminal, and other plate is connected to these negative terminals. So that's how they make more capacitance possible by using small dielectric. So it means that C equivalent. So as we know, parallel plate capacitance is just addition of all the capacitors. So in our case, we have all the capacitors with the same value C, and there are 1800 of them. So 1800 C. So C is this value. Now we know C equivalent, which is 10 power negative 6, and now we know the value of C as well. 1800 times 0.446 times 10 power negative 6 and K. So from this we can find out the value of K. So value of K, let me calculate that on my calculator, is oh, I'm sorry, this value here should be 10 power negative 9, not from here actually. So I'm performing this calculation. So this calculation gives me the value of K as 1.245. So let's approximate it to 1.2 because we are keeping only two significant digits. So that's the value of dielectric capacitance. So see the procedure, how I guessed how many capacitors there are. So what did I start with? I started with this particular piece of information to find out the value of D, which did not match with the given value of thickness. So that led me to guess there are more than one capacitor N, and then I found the value of that many capacitors, and then I tried finding one value of one capacitance, and then by assuming this structure I was able to calculate the value of K as needed. Thank you.